So we're going to talk about fault injection and fuzzing, defense measures to detect vulnerable code, and then Rust. So I get to the slides, which are here. Oh, by the way, you can see we're nearly to the end of the course. There's 2 chapters in the book here. Next class, I'm just going to do demos. I'm not sure what I'm going to do here. I might have some more machine learning projects, or maybe I'll do the chapter 18 from the book. And then there's the last class with no new material. So after that, it's the final exam. So there's only a few more classes and not much more material to cover in this class. But anyway, that's where we're at. And in Canvas, you'll find a chart that shows you what your final grade will be based on your total number of points. So everybody can look at that and plan how to get the grade they want in the time that remains. So, fault injection has been around for a really long time, and this originally came from people that had modems, and they tried using a modem during a lightning storm. And when the lightning struck, it caused the modem signal to drop some bits, and that caused the server to crash. And that's what started people thinking, what if you deliberately added errors in the data you were sending to a server? That could be a useful way to find flaws in the server, and it very much is. And now it's been used for a long time, by injecting spurious electric signals to electronic components. You can send electromagnetic interference, altered voltage levels, or many other ways. And this is part of quality assurance. Quality assurance is when you're manufacturing software or hardware, there's a quality assurance team that tests to see if the product has too many faults and shouldn't be shipped. And so you automate these tests, and you can also use manual techniques like reverse engineering and source code auditing, but then there's fuzzing. There's a very nice video here from Joe Grand, which is bloody awesome. Somebody came to him and said, I have a cryptocurrency wallet and I forgot the PIN to get in. And he went and Googled it and found out that the bootloader of that particular wallet had a defect, and all you had to do was send a voltage spike during the boot up process, and you could get it to crash before it had completely booted up, and you could freeze it at a point where the pin was present in memory, and you could read it off. And there are special hardware devices you get just to do this kind of fault injection, and it's very nice, and this is part of the world of hardware hacking. There's a nice YouTube video that's a lot of fun to watch about it. And like I say, I wish we had a course here in hardware hacking. This is a lot of what you do. You learn how to do this, and almost any kind of hardware is vulnerable to this sort of thing. You can suck the firmware out with the JTAG. You can reverse it with binwalk and other tools. You can examine the firmware, and you can mess with the hardware by doing this sort of thing, by cutting the power or putting in voltage spikes during the boot up, during processing, to force it to crash and catch it in partially interrupt processing in unexpected ways, and often do things you're not supposed to be able to do, like expose secrets. All right, so we're going to talk about design, fault monitoring, and so on. So here's the design overview. This is the basic essence. You generate network traffic of a normal network traffic. You use whatever the application server is the normal way and record the traffic with a sniffer, like Wireshark. Then you modify it. You modify the traffic with a fault injection engine. You modify it. You take the string values and make them long. You take the numerical values and change them to large and small values. You add random bit flips and things like that. Then after you inject these faults, you send that to the server and see if it crashes. So you try input. Here's input that will use the unusual IDA file type, and send this request up here with a cookie. This is a web request sent to something, one of those strange things in the IS web server that's not often used. Like I say, you'll usually find vulnerabilities in unimportant parts of code that are rarely used and forgotten about. They tend to have the most flaws. The part that you use all the time, people notice when they have flaws and they tend to patch it. The obscure little things that people have forgotten about are likely to have simple vulnerabilities. So you can manually build your fuzzing. This is, of course, the best way to get results, but it means you have to spend a lot of time analyzing the protocol. Automated generation is easier, but it might waste a lot of time trying buggy input that doesn't work. So one simple thing is just do a live capture and then inject faults directly into live network traffic. This is possible, but it requires fixing the frames. If you change the length of a field, you have to change the data size and the checksum and so on. So it's not so easy to do. What's much easier is fuzz injection. Like I said, random data injection found new faults. I mentioned this one when using a dial-up modem during a thunderstorm. And so there are open source apps like American Fuzzy Lop. These things are quite powerful. you have to recompile your source code with hooks, and then it will use those hooks to monitor the functionality of the program while you send up attacks and see what part of it crashes. If you have closed-sourced apps, though, like Microsoft apps, you don't have the source code, you can't recompile it, then you can only send modified input data without being able to put any hooks in the code. So you can have modification engines that do this. Now, you could just try randomly adding letters to this, but you'll probably create something with poor syntax that will just be an unrecognized request. What's much better is to inject by just repeating letters. So you could just take this injection, EEI 2003, and just try putting it in every possible location and see what that does. And a lot of these will just be invalid. You're wasting your time largely. If you use delimiter logic, then you would put it at the beginning of each word, keeping the spaces and everything and slashes and everything intact. This is more likely to work. Most of these will still be valid and accepted by the server. And another way you can do it, if you're not sure that new characters can be used, is you just try repeating existing characters. Repeat the T's, repeat the slashes, repeat the P's here. This is a way to make it longer to try to exceed some buffer on the other end, but be sure you're putting in characters that are acceptable. So these are various ways to make fuzz cases. So you make your network connection, you send all this modified data, and then you close the network connection, and you try to watch to see when the server crashes. Now, one thing that can mess you up is this thing called the Nagel algorithm. The Nagel algorithm will not send every single packet individually. If you send several small packets, it will group them together and send them all at once as one big packet to make the network traffic more efficient, but you do not want that happening when you're fuzzing. You want it to send just this strange packet exactly, so you have to disable it with a flag. All right, and then fault monitoring. You want to see what happened at the other end. One thing you can do, of course, is just ping the server to see if it's crashed entirely. Sometimes they do that. What would be nicer would be to use a debugger, as we did in our projects. You'd use a debugger. Then when you make it crash, you can look at the debugger. It will tell you which line it crashed on and what the values of the registers were and such. The most important exceptions are access violations. That indicates that you tried to read or write to some unpermitted address, and what you hope is that address is controlled by something you put in. And now you control a read, write, or execute operation on an address that you put in. Those are the easiest ones to exploit, and we've done quite a bit of them in the projects. All right, so a little bit about fuzzing. Static analysis is reading source code without running it, and you can find bugs this way. You might find statements that, for example, read input from something without limiting the length. But in fact, a lot of the times you'll waste your time. There'll be a line of code that does something that is not a best practice, but in fact, that line of code does not really have data that's easily controlled by the user. So even though technically it doesn't use the best procedure, it doesn't actually have any exploitation capacity. I've seen this a lot when I scanned websites to find vulnerabilities at colleges. I would find vulnerabilities, but they were in unimportant services that nobody cared about. They didn't really connect to an important server. And so, technically there was a flaw, but in practice there was not a significant enough vulnerability to be of any interest. So fuzzing is scalable, of course. If you build an SMTP fuzzer, you can test any SMTP server with it. And of course, a lot of strings will apply to any protocols like .. / many times just to try to do directory traversal and so on. So you can make fuzzers that are very generic. All right, but the problem is you won't hit all the code with a fuzzer. Fuzzers will just feed in inputs, and they'll go where various inputs can take you, but there's other parts of code they will probably never hit, like code that would require you to accurately fill out a form with a good name and address to get to the next page or something like that, or code that has to do with certain error conditions. And that's why, that's one thing to know about fuzzing. Doing source code analysis will scan the whole app, but it's likely to find parts of the app you can't reach from the inputs. Fuzzing will find only the parts you can reach from the inputs, which are arguably the most important to a vulnerability scanner. So just have to understand both of these techniques find different classes of vulnerabilities, and you should understand the reason to do each of them. Spike is a generic fuzzing product, which I used to give hands-on projects in this class, but in my opinion, Spike is so lame and ineffective. It pretty much works only on the Windows vulnerable app we've been using and not on much of anything else. And there are more complicated and sophisticated fuzzing programs, like one called Orange, I think, and American Fuzzy Lop. And they used to be very difficult to use. Now, Caitlin tells me they've gotten easier to use. So one thing I should do someday is write a modern fuzzing project for this class, but I don't have one yet, using one of the modern fuzzers. Apparently, they've gotten more easy to use. But anyway, Spike is a simple thing that will automatically fill in data. And so you can describe your input with a string, this will add the literal string. This will be a string variable, starting at this one, and then just filling it with a lot of strings out of a library of likely strings it has. And readline will read a message from the server. So you can fuzz vulnerable server with a simple spike file like this. We read a line from the server, you send it trun space, and then you send it random variables, starting with command. And this will, of course, crash vulnerable server right away. All right, and so when you fuzz the vulnerable server with Spike, it will only get to like the 7th or 8th one before it crashes. Or in fact, it crashed on the 1st or 2nd one because it quit reading, here's welcome to vulnerable server, and the next thing it sent was like 5004 capital A's, and that crashed it, so it was crashed from this point on, because it tries that right away. And you can, so it works to fuzz vulnerable server with this thing, but doesn't really work to fuzz much of anything else with it. And here's one of the many other products. Cluster Fuzz is, I think, might be a Google product, a way to have a cluster of things. And there's many, many fuzzing products out there that are more advanced. And I would like to have hands-on projects with them, but I haven't written those projects yet. So let's take a look at a Kahoot. All right, I guess we got as many as are coming. All right, which process do you have to disable for network fuzzing? The Nagel algorithm that combines packets. Can't have that. All right, what's most likely to be an exploitable exception? Access violation is the one that happens when you try to use data at an invalid address, and that's likely to be exploitable. It suggests that you managed to modify an address with the input data you put in. All right, which technique makes it easiest to determine whether flaws are reachable? Fuzzing? Fuzzing will only detect things that you can reach by changing the inputs. So anything you find with a fuzzer is clearly a part of the attack surface, something that can be reached by an attacker. All right, and which operation waits for the server to send a prompt in Spike. Read will read a line from the server. These will send a string to the server. All right. All right, I don't know if we know who SL is. No, that's not a student. But Rouhani is. So Rouhani will get points. The others may not, since I don't know who they are. All right, so let me stop this video.